We're surrounded by computers, from our laptops to phones to cars. By encoding digital bits of information using ones and zeros, on a basic level, the function of all computers is to compute, make simple and complex calculations. But what if a computer could make modern passwords and encryption obsolete, analyze drugs and compounds on the molecular level, and solve problems which would take a supercomputer millions of years to decode? Quantum computing is the answer. A very new and burgeoning field at the intersection of technology and quantum mechanics, there is still much to learn and unlock about this complex technology. To understand how it works, we have to revisit how a traditional computer works, and dive a little bit into quantum physics, or the physics of particles on a molecular level. Classical computers store information through bits, either ones or zeros. This is controlled by either turning on or off voltage to a bit. This way, computers can represent images or texts and make calculations. Quantum computers use quantum bits, or qubits. Instead of being either 1 or 0, these qubits are in a state of superposition, 1 and 0 at the same time. These qubits can represent any quantum system, like a single photon. The 0 and 1 represents the polarity of the photon, and until it is sent through a filter, forcing it to polarize either vertically or horizontally, it will collapse out of superposition to either 1 or 0. A famous example to visualize superposition is the famous Schrödinger's cat thought experiment. A cat in a box with a radioactive device which has a 50% chance of killing the cat. Until the box is opened to reveal whether the cat is dead or alive, the cat is both dead and alive at the same time, in a state of superposition. In a quantum computer, the qubit comes to rest either in 1 or 0. This is a very simplified explanation of superposition and the quantum mechanisms of quantum computing, but in short, using a string of qubits exponentially increases computational power. 20 qubits in a sequence can store 1 million values, as a qubit can either be 0 or 1 at any given point. Another quantum phenomena which quantum computing utilizes is entanglement. Two entangled qubits are linked together, no matter the distance, and they react to each other's state. Therefore, by measuring one entangled qubit, we can automatically deduce the other state as well. So how do we utilize the advantage of quantum computing? Quantum tech could revolutionize fields from medical research to communications to cybersecurity. For example, database searching. Instead of sifting through a large database one unit at a time, like a traditional computer, quantum computers can square root the time that it takes. Current computers are all encrypted by a public key, but thankfully, current computers would take thousands or millions of years to crack them. But quantum exponential computations would sidestep this by cracking passwords almost instantaneously. As quantum computers rely on quantum mechanics, they can measure and simulate molecular interactions, for example, proteins on the quantum level, and help us develop breakthrough medicines. Quantum internet, using a system of satellites, can create a global network using entanglement to send particles of data from Earth to space to a quantum computer anywhere else in the world. This sounds nice and all, but it's not like we're going to have iPhone Qs or quantum laptops anytime soon. This is because qubits are incredibly difficult to control. Any stray noise or heat will flip ones and zeros and knock out superposition. They also have to be controlled and held in place using electromagnetic fields and supercooled to function, and qubits often misfire and make computational mistakes. Quantum computing is a major breakthrough emerging field with lasting impacts with major repercussions throughout multiple sectors. It has the potential to either transform humanity's technological horizons or just be an expensive and ineffective research tool. Time, investment, and research will tell which one it is. Thank you.